Hi everybody. So in this video, I'm going to show you how we find the cross product of two vectors. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So we should know that the dot product of two vectors always gives us a scalar. The vector product of two vectors, say vector A and vector B, will give us another vector, which runs perpendicular to both A and B. So when we cross vector A with vector B, we get the normal vector that runs perpendicular to both A and B. And to work out how we do this, we're going to use this equation and each of these unit vectors. So I want to show you how we can cross each of the unit vectors together and then how we can use these products to find the normal vector between vector A and vector B. Okay? So if we start with I crossed with I, well, the A will be I and the B will also be I. The magnitude of A, 1 is a unit vector, so we'll have a magnitude of 1, so will B, and we'll multiply this by the sine of the angle theta, and theta is the angle between the two vectors, which in this case are both I, and because they run parallel together, the angle between them will be 0. So we know the sine of 0 is 0, so this entire right-hand side will become 0. So I crossed with I will be 0. And the same is true when we cross J with J. Because these are parallel, the angle between them will be 0, and the same for K crossed with K. So now, what I want to show you is how we can cross the remaining unit vectors together. And we're going to use the corkscrew method. Another popular method to use is the right-hand rule. But for the sake of this video, I'm going to use the corkscrew method. And the way this works is if we turn the corkscrew clockwise, then this will sink into the cork. We'll travel in this direction. But if we turn the handle anti-clockwise, then the corkscrew comes out of the cork, it travels upwards. So when we turn the handle clockwise, it goes in. When we turn the handle anti-clockwise, it goes out. And we'll see how this will help us. So if we begin with I crossed with J, the angle between I and J, you can see, travels in the anti-clockwise direction. So we're turning the handle anti-clockwise. So you can see that the corkscrew will come out. It will travel in this direction. And the direction it travels is in the K direction. You can see that they're both going vertically upwards. So in this case, I crossed with J results in a direction of K. I'll include that in the table as well. I crossed with J is equal to K. And this is not commutative, because if we cross J with I, we travel in the clockwise direction, which means we're turning the handle the other way. When we turn the handle clockwise, the handle sinks in, so it goes downwards. And when we travel downwards, this will be in the direction of negative K. If positive K goes up, negative K will go down. So J crossed with I will give us a negative K direction. Again, I'll show this in our table. So perhaps you want to try and cross I with K, K with I, and these two as well. You can pause the video, and when you come back, you can compare your working with mine. Okay, so welcome back. If we're going to cross I with K, then we're turning in the anti-clockwise direction. So we can show this on our handle. And because we're turning anti-clockwise, this is going to come out. So it'll travel in this direction. And if positive J goes in, then this will be the negative J direction. So I cross with K, negative J. If we're going to go from K to I, we'll turn this way. And this is clockwise. When we turn clockwise, we're going in, which is the j direction. And then for j crossed with k, I've had to change these axes around to orientate it. But for j crossed with k, we're going anti-clockwise. So this means we'll travel outwards, which is the I direction. And then for k crossed with j, we're turning clockwise. So we'll be going in. And this will be the negative I direction. Okay, so now we're going to use each of these values when we cross vector A with vector B. Okay, so in our second example, we're given that we have two vectors, A and B. We have the I component J and the K component, similarly for vector B. And we've been asked to show that when A is crossed with B, we get the determinant of this matrix. So the way we do this is if we write each of these vectors in IJK form, then we can think of this as expanding a pair of brackets, where we'll begin with this term crossed with this one, then with this one, and then with this one. Then we'll move on to the j terms, and then we'll move on to the k terms. So it's important to know here that we're not multiplying them, we're crossing them together as we expand out the two brackets. So if we begin with crossing this one with this bracket, then we get the I crossed with I to give us I squared, and then the A1 crossed with B1, the I crossed with the J, and the A1 crossed with B2, and then the I crossed with a K, and then A1 crossed with B3. And if we repeat the process for this term, then we get all of this. We'll repeat again with this term, and we get all of this. So now, the reason why we crossed each of these unit vectors together is to work out each of these cross products. We know I crossed with I is 0, so is j crossed with j and k crossed with k. So we can eliminate each of these three terms. We also know that I crossed with j is equal to k, and I crossed with k is equal to negative j. We know j crossed with I is negative k, and j crossed with k is positive I. K crossed with I is j, and k crossed with j is negative I. So now I'll tidy all of this up. And vector A crossed with vector B simplifies to all of this. So now we can group the I terms together, with j terms together, and the k terms together. So we'll factor out this I, and we'll get A2 B3 minus A3 B2. And we know that when we find the determinant of this 3 by 3 matrix, we're looking at a negative j term. So I'm going to factor out a negative j. And this will give us A1B3, which is this term here, minus A3B1. Then we'll factor out the k term, and we'll get A1B2 minus A2B1. So at this point, we should see that if we find the determinant of this matrix, we'll cross out this column and this row. So we need to find the determinant of this 2 by 2 matrix. This will be I multiplied by A2B3 minus A3B2. And that's exactly what we have here. If we move on to the j term, this will be minus j. We'll cross out this column and this row. Then we'll have A1B3 minus A3B1. And then plus the k. So we'll eliminate this row and this column. We'll multiply the A1 by the B2, take away the A2 multiplied by B1. And you can see this is exactly what we get when we cross vector A with vector B. Okay? In the next video, I'm going to show you how we can use this to find a perpendicular vector when we've got two known vectors crossed together. So thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and a PDF which accompanies this video from my website, mrmathematics.com. I'll leave a link in the description below.